Welcome to today's Roundtable webcast, brought to you by Aerospike, Attunity, and Hewlett-Packard Enterprise Data Security. I'm Stephen Fegg, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, Leveraging Big Data with Hadoop, NoSQL, and RDBMS. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if it's you. Now, to introduce our speakers for today, Brian Bolkowski, CTO and co-founder of Aerospike, Kevin Petrie, Senior Director at Attunity, and Rainer Kappenberger, Global Product Management at Hewlett-Packard Enterprise Data Security. For more information on our speakers today, you can click on the arrows under their headshots. Now I'm going to pass the event over to Brian.
Hi. Thanks for attending today. I'm going to be talking about new architectures that we at Aerospike are seeing regarding big data. Aerospike first made its database available in 2010 and immediately found success in the advertising and marketing technology community. Within Aerospike, we found that the need for fast, effective analytics on very, very large data sets within advertising. These are the cases where you keep behavioral information on billions and billions of cookies throughout the world and use effective math to find new patterns and make money. Within Aerospike, we are a system that is a NoSQL database that provides speed at scale. This means multi-terabyte data sets with billions of objects and extraordinary high speed. The fact that we have excellent clients as well as high availability clustering means that our speed not only gives you low TCO, but also great capabilities. We find that compared to other NoSQL databases, we can reduce server costs compared to, say, Cassandra, which uses disk databases or in memory with CPU problems, or the ability to have clustering, which is not available with other in-memory databases. The architecture that we've seen in the last few years in advertising and internet companies is starting to flow through to enterprises. And let me take you through a few of what that means and some of the technologies we've seen. Some of the other presenters today will also show some analytics capabilities that relate to this. Today, when we talk about big data, we primarily talk about Hadoop, and we talk about Hadoop-related analytics, with some people working with streaming systems such as Spark. In reality, what we've seen at Aerospike is a wide variety of analytics solutions, from column databases like Vertica or Redshift in Amazon, as well as graph databases such as Neo4j. Relational databases still play a role with large-scale ad hoc queries being done on fairly big data sets. Big data, as we see it, is not just petabyte Hadoop clusters, but is actually a combination in the Polyglot world of a variety of analytics systems. Those analytics systems thrive because there is installed base of people who know those systems and can make them sing, as well as math and effective analytics that are already being done in those different systems. Those are almost more important than the gravity of the data that is stored in each one of those analytics systems. Because of the different data shapes required, that polyglot system within analytics, we believe, will last for a long time, and we may even see more analytics systems being created. Already, machine learning is creating back-end analysis of behavior, often through big data, creating neural models that can be deployed operationally. On the left-hand side of this diagram is where Aerospike lives. And what we find is the ability to take those analytics and not just present business intelligence support and provide presentations for long-term planning, but also the ability to, on a moment-by-moment basis, make decisions and support real-time, richer user experience is through your web experiences. So let me take you through how that seems to work. The box labeled operational in memory has really become owned by NoSQL solutions. Although it's possible to have SQL solutions run in memory, or some of the older in-memory solutions, such as Oracle's ×10, what we have found is that between clustering and the ability of Flash, systems like Cassandra, Redis, Aerospike, Couchbase, and a variety of others have come to rule operational in-memory systems. There is still a role on the front operational side for transactional databases. We still find that when business models, when compliance, and other factors are available and necessary, you still need a transactional database, whether that be Oracle, DB2, or any other large transactional system that has been through compliance and testing. In these systems, you end up having a rich application server architecture. This could be driven by a system like Pivotal Cloud Foundry or other orchestration mechanisms such as Docker. But the important point is in the new world that those application servers are stateless systems that are either cloud or containerized because you don't know ahead of time what amount of CPU you're going to need in the future. So what we see is we see next generation architectures still using systems like Java, but also new systems like Node, and deploying microservice or API managed systems. This is really a return to the past because this is an SOA architecture from years gone by. So many of your two-speed IT and customer 360 views are still driven around this kind of system with application servers and application models driven by NoSQL databases. The benefit of using NoSQL in these systems is the fact that you'll be able to use new data sources. So instead of simply having your Hadoop architecture being put into a system with, instead of having a system where you have a cache and a relational system, we often find a lot of problems in those operational databases that are now addressed by a in-memory operational system such as a NoSQL system. So in the old world, operational databases were under a greater and greater load due to the needs of new applications such as mobile, such as real-time pricing, and such as real-time decisioning. In the case of travel, for example, there were a lot of problems a few years ago where real-time pricing and look-to-book ratios were becoming harder and harder to support with older school operational systems. The first attempt is to put a cache layer in front of it, which causes a number of operational problems. The caches are out of sync, it's another layer to manage, and still you need a full-on transactional system to actually do all of the booking. This becomes a more and more complex system as you need to take those back-end big data systems and leverage that data. So what we're finding is an operational system that also includes a next-generation NoSQL, a next-generation operational database. What you should be looking for in your system is the need for new applications. When you have a new desire to take big data systems online, when you have pricing that needs to be moved from days of price changes or hours of price changes to the desire to update prices in minutes, or you find that operational load where you have applications that are richer and richer, and your application developers keep asking for more database requests, and why is my application too slow? And your full stack monitoring system starts saying the database is the problem. You need to start considering NoSQL solutions. You'll start finding, as you switch to next-generational operational databases, the ability to use the insights that have been created with your big data systems, such as Hadoop, such as Spark, and even, for some leading-edge people, machine learning. I'd like to go through a few cases that we've seen in enterprises where Aerospike has been, and next-generational operational databases have been successful in addressing customer needs. So the first one of the problems we've been addressing is fraudulent transactions within payment processors. Payment processors have two significant business problems: false positives and false negatives. With the switch to chip and pin within payment processors, the ability to detect fraud in brick and mortar stores is going down, but online fraud has actually been increasing according to most metrics. Online, though, you have big data capabilities and the ability to bring in more and more different kinds of behavior in order to try to make effective answers within your payment processing system. So the business challenge several payment processors reached out to us is the need to touch more and more data to make a business decision. Instead of a rules engine with simple thresholds, they wanted to start looking at using machine learning, using internet data, such as information from all of the IP addresses attached to their website, as well as simple behavior within associated web pages to make tighter and tighter fraud determination. Now, of course, there's interesting problems of privacy and legality around bringing in new data sources, but the need for a new database to address those problems was absolutely necessary. The solution that they found was building out more complex application logic. They found that instead of having a very simple relational rules engine, what they needed to do was bring in Java code and write their own Java code and applications. Now, of course, this is going to be the kind of technology accessible for the largest payment processors with their own teams. However, they really need to get a leg up on their competition. We find for smaller payment processors and smaller banks, the ability to use data as service and fraud services, those kinds of fraud services will be using the kind of cutting-edge math that requires the kind of next-generational operational database like Aerospike. Another case where we've seen operational database power is systems of record within within financial services systems. And that's often driven by, first of all, real-time risk recalculations, as well as the ability to provide richer application support, such as mobile. Different vendors wanted to be able to show on one device when you make a trade, the correct trade status, so the trade is now pending on the mobile device. And people today in the internet world are not willing to have a lag of even a few seconds between those experiences. This is the kind of architecture where also you need a transactional system underneath that does end-of-day reconciliation, but a reliable in-memory system that is data correct throughout the course of the trading day. Again, the key to this architecture is to have an underlying transactional system which is well accepted, well known, but a front end which is the system of record. So no longer did they have the problem of cache inconsistency and a separation between those two systems. Within advertising technology, as I mentioned, there's been a huge need, but this need also has been driven by retailers. More and more retailers are working at the scale where they have programmatic ad spend and specific deep integration with advertising sources. We see larger retailers like eBay, Williams-Sonoma, and Walmart with large big data experience needing to make changes in product recommendations, but also in user experience from moment to moment. Finally, we're also seeing this trend within telco. The case within telecoms is the ability to make billing decisions based on data as opposed to call records. Call records are only updated once every minute or so and still need to be tracked. But most data plans, most cell phone plans in most parts of the world now give unlimited talk and give data pricing based on every single byte that is transmitted in their network. In order to make routing decisions based on customer account status, in order to do traffic shaping for reliability, and to provide innovative services such as scale back for certain video services, the need to be able to have billing on a packet-by-packet basis throughout an entire network requires an entirely new operational system. This is still a system where there is a transactional database for large-scale account status, but not every packet and not every session is written through to that system. Hopefully this overview of using big data in an operational sense has been useful and has sparked some great ideas for projects that you've got upcoming. Aerospike is an open source database and can be freely downloaded so you can experience the power of it and see if your developers and operations staff can build new and exciting projects. I'd like to hand it back to the moderator now. Thank you for listening.
Thank you very much, Brian. At this point, we're going to move on to our next speaker today, Kevin Petrie, Senior Director at Attunity.
Great. Thank you, Stephen, and thank you also, Brian. That was a very good segue to what I'll be talking about today. The gist of what we're going to focus on here is that enterprises today have a problem. It's an opportunity, but it's also a problem, which is that there are specialized new platforms that will optimize different workloads. And that'll increase the overall value to the business. It'll help them compete better, help answer customer needs more effectively. But platform proliferation can make the management and the cost burden prohibitively high. So most enterprises already have multiple data platforms on site. This will include conventional databases and data warehouses. Cloud is often a simpler foundation for some of this, but those are also additional platforms to manage. And the last thing that we find enterprises need to do, and I'm sure this will include a lot of people on the phone, is increase their management burden. So this really contributes to an economic imbalance that, as a company, Attunity is laser focused on addressing. The challenge here is that there's really a surplus of data now. There are increasing volumes, velocity, and variety of data that have provided the organization, and by extension IT, with a surplus of data. However, the challenge is extracting analytical insight from that. We worked with Forrester Research on a survey and some estimates in Q4, and their estimate is that enterprises actually analyze about a third of the data that they have. So not all data holds value, but that's a pretty low ratio, and I think it indicates that there's an imbalance here. Customer and operational questions are going unanswered, and so value is going unrealized as a result. And if you're not developing insights from your data, your competitors are probably doing it with their data. So as I said, as a company, Attunity is laser focused on addressing this deficit and the underlying IT bottleneck. Drilling in on that, the specific challenges that we're focused on, and this is very germane to the question of how you have relational databases and NoSQL, including Hadoop, how all those things can coexist. The three key challenges that we see, and I think this is complementary to what Brian talked about, the challenges that they're addressing. One is that data integration across these heterogeneous environments and new platforms is complex and costly. It often involves manual ETL coding that unfortunately ties up your best programmers. Second challenge would be that most of the existing tools require a lot of manually intensive processes, and it'll tie up, again, those skilled resources. That applies to ETL, which I talked about in the first point, as well as the creation and management of data warehouses. The third challenge here is that data managers increasingly need insight into how the business is actually using the data, because that can help you make optimal decisions about where data should reside, how you can improve the performance of analytics queries, and how you can reduce cost. As I mentioned, we did work with Forrester in Q4. One of the findings, which I thought was very interesting, is that enterprise IT decision makers at the strategic level are very interested in getting these insights on data usage, and about half of them were doing these very manual efforts to create manual scripts that can track that data for them. Our goal is to provide that in a very intuitive and automated fashion. Okay, so quickly looking at our platform, our solutions for enterprise data management. We have three pieces here, and I'm going to be talking the most about Attunity Replicate. Attunity Replicate will enable you to move data very easily in an automated fashion across a broad set of heterogeneous environments with no manual ETL coding. So you can simply point to your source, point to your target. It might include a relational database. Maybe you need to do query offloading. That's probably our primary use case right now, helping people copy data from their system of record in the relational database over to a data warehouse, potentially copying it from there over to a new NoSQL platform like Hadoop. So that's what Attunity Replicate is all about. The second one, Attunity Compose, enables you to automate the process of creating data warehouses and data marts, again, without coding. Again, it's a point-and-click browser-based interface. Final point or part of our portfolio is Attunity Visibility that will give that usage insight, the BI on BI, if you will. It'll provide insight into how data is being used by the business and how that impacts the underlying resources, which will help you optimize data placement, performance, and cost. Okay, so Attunity Replicate. This is a single centralized solution for the enterprise and the cloud. We support more than 35 sources and targets, which includes all the major databases, data warehouses, Hadoop, NoSQL platforms, on-premise, or in the cloud. So you can configure, manage, and monitor the movement of your data to AWS, Azure, Google Cloud. You can also do it to the primary databases that historically have been used on premises, which would be Oracle, SQL Server, and so forth. Okay. I want to add a quick note about visibility. As I said, what we can do is provide a very intuitive look into metrics about data usage, and this is particularly germane to the topic at hand, which is figuring out, okay, you have a data warehouse, your system of record residing with holding tabular data, and you also have Hadoop in a lot of cases. How do you figure out what to put where? With Attunity Visibility, you're going to get an understanding of ETL and analytics workloads, and thereby find data that might be tying up a lot of EDW resources but is not getting touched. That data, that sets of tables, those databases within the data warehouse are prime candidates to offload to something more cost-effective like Hadoop and or the cloud. Visibility can also help enable chargeback and assess the return on investment by measuring table usage, column usage, Hadoop file usage as well. Okay, so what does all this mean to the topic at hand here? There are a lot of different ways to slice and dice platforms. The three big categories that I'll focus on here boil down to relational databases, the data warehouse, and NoSQL. So we have the relational databases that typically handle the online transaction processing. Then we have data warehouses that for 30 years have hosted analytics activities for the business. NoSQL are these non-relational databases, I think as most folks on the line know, that'll manage data without those traditional database tables. This helps with fast, often ad hoc analysis of high volume and disparate data types. Hadoop is a great example. This is a hugely popular open source framework that'll process big data in a distributed environment across clusters of servers using pretty simple programming models. So to drill in on the comparison here, relational databases and data warehouses handle data that's typically structured. NoSQL, whether it's Hadoop, Cassandra, MongoDB, can handle both, and it's often an unstructured data where you're really going to use Hadoop. The architecture is distributed when we get to these new NoSQL environments. They're more scalable. They have higher throughput. They can handle workloads that might be processing things in a batch basis for analytics, or if you're using things like Apache Spark or you're using Apache Kafka on top of new open source platforms, primarily Hadoop, then you can do things in a more real-time fashion. So I think the key point here is that the new NoSQL platforms, again, primarily Hadoop, are giving you that flexibility to scale, to process things very cost-effectively, to leverage distributed architectures that can scale very quickly. They'll also give you flexibility in terms of the types of data that you can store and process, and will help you iterate your data model in a more flexible fashion. So in a nutshell, what we find most organizations doing is maintaining the relational databases, the oracles of the world, for online transaction processing. They're offloading structured data analytics to the data warehouses. That's been going on for some time. And again, that's a big part of our business. A lot of the new structured and unstructured data analysis, that experimentation, the discovery of new types of data, and the assessment of those to discover new business opportunities increasingly is taking place within NoSQL. Within that, Hadoop is particularly interesting because it's so cost-effective and so highly scalable. It's also the nexus of so much open source development. So Apache Spark, Storm, Kafka, and many other examples show how you can, A, speed up the analytics, and B, really do some new things with data and address new business opportunities. Okay, so what I'm going to do is go through and talk about how Attunity Replicate can play with some of these primary NoSQL platforms. Attunity Replicate will provide a single consistent user interface in order to ingest data into Hadoop. And you can do this either through change data capture, which will relay row by row updates, instant data updates from various files or various databases into Hadoop. That can support a variety of use cases, for example, using Apache Spark or Apache Kafka in order to assess data and capitalize on the business opportunity that it represents in a real-time fashion. We can also support bulk loading, and so we could load a whole set of historical records into Hadoop. And the key benefit here is if you want to do a bulk load, you could then automatically transition from bulk to CDC in order to keep the data that you've moved over consistent. The use cases here are myriad. There are many, many we could go through. I think one of the key points is that you can correlate transactional records with unstructured data. And you can integrate new types of data for real-time analytics or deeper insights so that you can get, say, a 360-degree customer view. Another interesting use case for Hadoop is that Hadoop in some cases can more efficiently transform data that would then go back to the data warehouse in order to have structured analytics run on it. So Hadoop can be sort of a staging area, a transformational staging area to transform data, put it in the right format, and then get it back into the data warehouse. Each of these data moves that I'm describing, Attunity Replicate can support, again, with an intuitive graphical interface that eliminates the need for manual coding. Another primary example of NoSQL databases is MongoDB. So MongoDB derives from humongous in terms of the name, which is an interesting bit of trivia. It's a cross-platform, document-oriented database, and it makes the integration of certain data types in applications easier and faster. It works well with small-scale operational or first-level analytical exercises. Some of the use cases here include a 360-degree view of the customer in terms of their preferences, their activities, and so forth. Another use case, which underscores the degree to which MongoDB and Hadoop will be coexisting, is that you could have batch analysis run in Hadoop. Again, Hadoop with the MapReduce engine is very efficient and at batch analysis. So you could run it in Hadoop, churn out the results to MongoDB, and get some new views by looking at the results in MongoDB. So these are just a few of the ways in which we're, again, porting data in a much easier fashion across the various types of databases, in this case Hadoop and MongoDB, that increasingly will coexist with the core relational databases. Well, my slide seems to have stopped here. Bear with me for one moment. Okay, good. I know we're running up a little bit on time. I'm going to briefly talk about Attunity Replicate for streaming into Kafka. And what we're doing here is broadening your big data ecosystem. So we'll integrate with Apache Kafka APIs in order to ingest high data volumes from a lot of different sources. You can use the same interface, the same underlying automation technology as with other platforms, and deliver data from all those other databases, data warehouses, and so forth into Kafka clusters of servers, which are known as message brokers. And as with other platforms, we're going to provide integrated management and monitoring of all those data moves through an intuitive console. The value with our Kafka integration really boils down to consolidating massive data volumes, potentially across multiple sources and multiple targets. So some of the use cases for Kafka include website analytics, and I think that was part of the initial genesis of this at LinkedIn. Understand how you can engage prospects that visit your website based on highly granular activity tracking. What we do is deepen the Kafka use cases. For example, combining transactional records that you might get from the relational database with new external data sources. So in terms of the how the data moves here, as in other platforms, we're going to send data through CDC or bulk load. We're going to send it to these Kafka message brokers, which in turn can relay the data streams to a variety of NoSQL databases. Apache HBase, Hadoop, Cassandra, Couchbase, and MongoDB are the examples that we've got here. We recently closed a deal with a Fortune 100 manufacturer. We serve about a half of the Fortune 100 account base. And what we're doing here is helping them perform massive data consolidation across 4,500 applications, spanning primarily platforms that include mainframe, DB2, SQL, and Oracle, putting it all into a big data lake. That's going to involve Kafka data brokers as they figure out what they want to relay on a real-time streaming basis to a broader Hadoop ecosystem. And so Attunity Replicate will integrate all these sources and targets, which makes it feasible. It takes that prohibitive labor and that prohibitive cost out of the mix when you talk about these larger multi-platform architectures, or I thought what Brian aptly called polyglot architectures. Here are a couple more examples, or a few more examples, of the economics of the advantage we can provide, which is really helping people improve compliance, but more importantly, manage more data more economically. As you can probably tell, partner ecosystems are critical to us. We've been partnering with all the big companies for a long time, and we're partnering with the new providers such as Hortonworks and so forth in order to expand the ecosystem that we can support. Okay, so I'm going to conclude here with a quick note on when you look at data economics. There are really two ways to improve what you're doing. I talked about an analytics deficit before. You need to use data more efficiently in order to reduce the cost piece. Converting more data to insight faster, delivering more data ready for analytics to the business can improve the value piece. So on both sides of the ledger, we're trying to help organizations manage more platforms, deliver more data, reduce that surplus of data you have in order to deliver more data ready for analytics to the business. Okay, good. Stephen, I'm going to hand back to you and appreciate your patience.
Thanks a bunch, Kevin. At this time, we're going to move on to our final speaker today, Rainer Kappenberger, Global Product Management at Hewlett-Packard Enterprise Data Security.
Thank you, Stephen, and for the introduction. So to give a little bit perspective on Hewlett-Packard Enterprise on the data security side, what we are all about is we're really about protecting the most sensitive component that any company has, which is actually the data itself, and trying to help people to neutralize breaches in that respect. So this is done to help you do data de-identification and provide compliance for privacy regulations that are existing by providing security for your data when it's at rest, in motion, and even when it is in use. So this solution, which is actually NIST compliant, it is a form of AES called FFX, which just was recognized by NIST. And as part of this, I'm going to go through and how this can be applied to your big data ecosystem. And for data security, it's really applicable to all different people inside a big data ecosystem, whether it's from an architect, analyst, business owner, security, and even the executives should consider data security, because it's frequently an afterthought in a lot of implementations that we have seen. But what we've also seen, people that actually take a more proactive approach to the data security component in big data ecosystems have been able to scale much faster, much larger for their environment, because the confidence on all the different elements, whether it's from a security, from an executive level, or a business owner side, has actually been very favorable because now they can actually collect and analyze more data than they've been able to before. So with that, why is actually securing Hadoop and especially big data so difficult? Number one is a rapid innovation in a well-funded open source community. When you look at the pace with which Hadoop has been developed, and as people that were at Strata Hadoop just celebrated its 10th anniversary. And when you look back over what was achieved in 10 years' time with Hadoop, it's at a scale and flexibility that has not been achieved in the past. Things change extremely fast. New projects come up because there's new use cases, whether it's on the IoT side, where it's more about machine-to-machine communication. Storm, Kafka, Flume, and the like come to mind, but also on all other aspects in improving the infrastructure. The second part, what makes securing Hadoop really difficult, is the multiple feeds that you actually take in, whether it's data that you collect from other database systems or even mainframe XML files, data from other outside sources. Could be Salesforce, it could be tapping into social media streams and the like, but this creates just a data problem by itself, where the different data types all are going to be combined in the big data environment or the data lake. So what can you really do to help minimize any security problems? And for that, let's look at what traditional security actually provides. And traditional security is a layered approach. So you do different protection at different layers. So for example, when you deploy disk-level encryption, what are you protecting against, and what are you trying to avoid? At the end of the day, what it provides you with is improper disposal of hard drives, whether that's accidental, somebody did not shred the hard drive correctly, or somebody walking into the data center and stealing a disk drive. But as soon as the drive is inside the computer and operational, then the data is in the clear. So you just do storage level at-rest protection. So when you step up, for example, looking at the database level encryption, let's take, for example, Oracle TDE or the Hadoop transparent data encryption, what are you doing at that point? So at that point, yes, the data is protected on the disk. It is protected on the file system, so your administrators no longer have access to the data. The database itself is protected, but for example, in an Oracle environment, any SQL query will run in the clear. And as we've seen in today's attacks, the people are not going after the disk drives and stealing them from the data centers. It's more about SQL injection attacking the application layers. So you're still not protected at that layer. So each of those layers has a gap in between that you need to address because they only can protect downward. So when you look at data-centric security, it actually provides security and protection of the data in all different layers, at rest, in motion, and in use. So how's this done? The way to do this is by using format-preserving encryption. As I mentioned before, this is a form of AES encryption that has been recognized by NIST and the form of FFX in a recent publication, 800-38G, done by NIST just a few weeks ago. And this allows you to encrypt information like social security number, credit cards, emails, dates, any kind of information and any kind of formatted data in a form that the end result looks like an original data. So a social security number or a credit card looks like a credit card. An email looks like an email. So you don't break application logic. You don't break the capability of doing analytic processing on the protected data. So when people actually use a social security number, they use it typically for referential integrity because it uniquely identifies a single individual. So this is still possible when the data is encrypted. You can still link the information just as you were on the live data. But in case somebody taking an extract from your Hadoop environment, putting it on a developer machine, no live data is actually exposed in this process because the encrypted data, the developer cannot decrypt the data. So how do you apply this data-centric security format preserving encryption in your big data environment, whether you're using the regular Hadoop components or even a NoSQL database like Cassandra or MongoDB? So this solution is actually applicable not only to the Hadoop environment. You can do this on mainframes, HP Nonstop, Teradata, Vertica, whatever you might have. There's a solution to actually protect the data outside. So in this case, you just transfer data internally and process like you were normally doing. But the second possibility is like you're taking data sources that aren't yet protected. You can do this by via Scoop, or in case of you having an IoT environment as well and you need streaming data, this can be done inside of Flume, Storm Kafka. So when data is received, you can protect it and analyze in its protected form. Sometimes these ingestion approaches are not feasible. So the typical approach people would take in order to support data protection at that layer is actually ingest the data in a transparent data encryption protected zone within Hadoop, and then using MapReduce to protect the information at that point. And the beauty of all of this is that you can do almost all of your analytical jobs can run in the protected form. That means you do not decrypt the data. Typically, developers or analysts would say, but I need the data in the clear because I have this clear text social security number that I'm looking for. Well, the solution to that is very simple. Encrypt that social security number and search for the encrypted value. You get the same result without ever decrypting your huge data set. But as with any kind of analytical software, ultimately you need to decrypt the information because you want to act on your result set. So let's say you've identified the top 10 customers, you want to send a mailing to them, you can still decrypt the data, Hive, MapReduce, or whatever tools you're using to actually perform the mailing to send them a coupon or whatever you want to do. There's a lot of people that actually use big data on the Hadoop side with other systems like Teradata, HP Vertica, and similar. And you can exchange data in its protected form between those systems as those systems are supported in this environment as well. So one aspect that typically comes up within encryption as well is key management. And as many people know that are a little bit familiar with encryption, it very quickly can turn into a key management problem. The key management solution from Hewlett-Packard Enterprise on the data security side is actually stateless key management, which means there's no key database to store or manage, which gives a high performance, more scalability because data needs to never be replicated between key servers. And even if you operate a Hadoop cluster out of multiple data centers, there's never a chance that a key cannot be found because the keys are always generated on demand. The solution, as I explained before, is available on many different environments because customers of ours are actually using it on premise, in the cloud, big data, on structured and unstructured data, on many different operating systems. And it gives an extremely fast time to market. So let's look at a specific use case. In this case, a telecommunications company. They have several 100 million customer records that they wanted to analyze to better understand customer behavior, so to better optimize their retail experience and better understand customer churn. so that they can offer the right solution for the customer at the right time. Because the most expensive part for any company is obtaining new customers, and it's hard if you lose a single customer. It's costing you 3 times as much to find a new one than actually retaining the existing customer. But the problem with those environments is it contains a lot of PII information, because you have the log data, activity data from when people use phones and the location that they've been with their mobile phones, log data from different environments. So overall, in this particular instance, the customer had 17 data fields that they deemed on their side are sensitive and need protection. But not only that part, they also ingest about 300 million customer records in less than 1.5 minutes into their system, and that should not be significantly impacted. So the way that they've been solving their problem is actually integrate the HPE secure data into their ingestion workflow. So whenever data is hitting Hadoop, it is processed with scoop and MapReduce jobs and similar things to actually protect those 17 data fields using format-preserving encryption. As part of that, there's almost all of the analytics that they do is done on the protected data. Because ultimately, when you look at it, the analyst, he's not going to make the recommendation to a customer. He's not going to make the determination of or doing the actual action. He does not need to understand who the person is. All he needs to understand is these are the top 10, or this is the appropriate action to take for a particular set of customers, but he's not acting on it, so he doesn't need the PII information at that point. So all the integration in there and doing the 300 million records, which contain the 17 data fields. So at that point, you're looking over 4 billion encryption events, has taken less than 90 seconds of additional ingestion time frame. But what they also realized is this technology is not only good for their big data environment, which actually is over 1,000 node cluster today. Is also very good for them to actually protect data in different other systems, whether it's on mainframe, ZOS, Oracle, or any other kind of environment. So the big part to remember in this area is big data environments just create a bigger risk of exposure against attacks, because you have to consider that during an attack, the first thing the attacker does is build a network map understanding where your data is and how to make use of your data. You've done with big data 99% of the job for them, because if they find Hadoop, you've consolidated the data, you've provided all the linkage points between the data, and at that point, their job is relatively easy. Big data platforms provide very good core capabilities for authentication, authorization, and auditing, but all of this should be supplemented with Datacentric security that actually provides security for your data at rest, in motion when it's on the network, or in use in memory. And it actually does maintain the value of the data for analytical purposes. And that way, it enables you to run a secure big data environment that allows you to make rapid business decisions and improve the big data environment tremendously. With that, I would like to hand it back over to Stephen.
Thank you very much, Rainer. At this point, we're going to move into questions from our viewers today. And the first question is for Brian. Brian, how would you use Aerospike and machine learning?
Yeah, that's a great question. So a few of our customers and users, both open source and paid, have been using Aerospike and machine learning. Part of the problem with the newer in-memory machine learning systems is they support the ability to change and update the model in real time based on existing behaviors. This is called online learning. as opposed to actually like going to a class online. So with online learning, you need to have a whole bunch of compute servers crunching the numbers and getting results out and updating models. But you also need to have a shared data store. These objects are between 3 megabytes, 30 megabytes, 300 megabytes, which is far less than a gigabyte and seems pretty simple but to store in a database, but there are few databases that can store it. With Aerospike, I'm seeing that people are splitting that into separate records, but actually storing those models online, which means that immediate changes and with online learning can actually be pushed to all of the compute servers. It's a pretty interesting architecture.
Understood. Thank you, Brian. Kevin, our next question is for you. What Hadoop cloud offerings does Replicate support?
Great question. So we support all the major cloud providers, and we support Hadoop on each of them. So that's Amazon Web Services, Elastic MapReduce, or EMR. It's Google Dataproc, and with Azure we support blob-based data lakes.
Understood. Thanks, Kevin. Reiner, our next question is for you. Would you be able to clarify when you recommend using encryption versus when to use tokenization?
Sure, absolutely, and that's a typical question that we see quite frequently as well. Encryption should be the default for anything except credit cards. For credit cards, people should be using tokenization because that allows to reduce the PCI scope during audits. So we've seen a lot of cases where people were reluctant to store credit card information in Hadoop because of the cost of PCI audits. Using tokenization correctly, and they've been able to avoid the PCI audit and reduce the potential cost in there tremendously. So yes, tokenization should be used for credit cards.
Understood. Thanks, Reiner. Brian, back to you. Would you recommend Aerospike for blockchain use in financial services?
Yeah, great question. So blockchain is a pretty interesting new technology within financial services. Blockchain is a way of doing distributed transactions with what's called an open ledger, where the ledger, the actual account statements, are entirely in the open, available to anyone, and validated through cryptographic means. Blockchain is the technology behind systems such as Bitcoin, which allows anyone, anywhere to transfer money without the ability to, the need of using something like a bank. The problem within blockchain technologies today is entirely one of scale. Many different industry analysts are saying that looking at that ledger, the additions to that ledger, and then actually validating a transaction is pushing the capabilities of big data systems. This fits exactly within the model I was mentioning earlier on with operational big data. That's an operational problem. I have a transaction coming in, I have a bigger data load, I have an interesting new cryptographic and transactional technique that I'm trying to apply. So Aerospike can be used as that ledger and support then the ingest of gigabytes of new data per day, and eventually then terabytes and terabytes of storage. A number that doesn't seem crazy in today's big data world, but is in fact a serious problem using traditional databases for blockchain storage. So we really think that Aerospike has an interesting future in blockchain technology.
Understood. Thanks, Brian. Kevin, back to you. Can you elaborate on how Kafka affects the role of the data warehouse?
Yeah, it's interesting because the Kafka in many cases will be sending data to these Hadoop ecosystems, these larger NoSQL ecosystems, which might include Cassandra or MongoDB and so forth. It could also send it to data warehouses. And so I think that we need to keep that in mind. Generally, the core data warehouse will continue to be a very major part of these multi-platform architectures for enterprises. I think on the margin, Kafka does increase the use cases for sending data to these non-data warehouse platforms for a couple of reasons. One is that those non-data warehouse platforms, those new NoSQL platforms, can accommodate more types of data. They can scale very easily, and they can be cost effective with their processing. All those things become more and more appealing with something like real-time data streaming, which increases the volume quite a bit of the data that you're trying to manage.
Understood. Thanks, Kevin. Reiner, our next question is for you. Why isn't the authentication and authorization you typically have with Hadoop and other big data platforms sufficient? What about database encryption?
Yeah, that's a good question, because a lot of times people think they've protected the data by having authentication, authorization parts in place, and what we've typically seen is that insider attacks happen, or also that credentials are compromised. So this typically then leads to data leakage at the end of the day, which people try to avoid. So the same is true for transparent data encryption, which actually exposes the data on higher levels. So applications and SQL injections still have the data security problem. So the better way to actually protect is if you encrypt the data, and the analyst only sees encrypted or tokenized data at that point. You remove all risk of them making copies, whether by accident or somebody just compromising their credentials. They have no access to the live data at that point. So it's a much cleaner protection of the data itself.
Understood. Thanks, Reiner. That is all the time we have for questions today. We apologize that we were unable to get to all your questions, but as I stated earlier, all questions will be answered via email. I'd like to thank our speakers today, Brian Bolkowski, Chief Technology Officer and co-founder of Aerospike, Kevin Petrie, Senior Director at Attunity, and Reiner Kappenberger, Global Product Management at Hewlett-Packard Enterprise Data Security. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived, and you will receive an email tomorrow once the archive is posted. Plus, if you would like a PDF of this presentation, you can click on the resource icon at the bottom of your console. Now, as we stated earlier, just for participating in today's event, someone would win a $100 American Express gift card. And the winner today is Jesus Liu. Jesus, we will be in touch via email so you can claim your prize. Thank you, everyone, for joining us today, and we hope to see you again soon.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating.